Okay, so let me share my screen now. Okay, so we are now on first order differential equations, but this time we're not talking about separable first order differential equations nor homogeneous first order differential equations. So now we'll be talking about exact. So exact differential equations. So just like the first two, so in separable differential equation, you need first to determine whether your functions are separable in such a way that it goes with a differential which contains its particular variable. So meaning functions of x should be with the differential of x and functions of y should be with differential of y. If these two are mixed and if there is no way for you to separate such functions, so maybe your first order differential equation is not in the first place separable. So you need to look for another method for that or for another type in which it will be falling under. Okay, so in terms of homogeneous differential equations, as discussed last meeting, so this is just a form of review, there's a need for you first to test for homogeneity. So your functions, the coefficients of your differentials have to be first tested whether they are homogeneous. Now, if they are homogeneous, the degree of these coefficients of your differential should be equal. That way, your differential equation is said to be first order and homogeneous. So for today, for exact differential equations, you need also to test. So there's a test that you need to perform before you can use the processes that will be, or the procedure and steps that will be discussed. So let's go to the first slide. Now, let's say your differential equation is of this form in which you have the differential of x and y, and it has coefficients which has a mix of variables x and y, or could be also solely in terms of one particular variable, either x only or y only. So if m and n, so if for m and n, the partial derivative of m with respect to y and the partial derivative of n with respect to x are continuous functions of x and y, then a necessary and sufficient condition that m dx plus n dy is equal to 0. And this tells you that your differential equation is exact. So the test for the exactness of a differential equation class actually is the last relationship that we see in this statement. You have to take the partial derivative of m. So let me annotate. You need to take the partial derivative of m with respect to y. So the m that I'm referring to in here, class, wait, class, wait, class, cannot. Okay, so the m that you're going to get the partial derivative of is this, the coefficient of the differential of x. Okay, the partial derivative of n with respect to x will be this n here. So whatever are the expressions or the coefficients of the differential of x and y that is written in your original differential equation, you will partially differentiate them with respect to y and x for m and n respectively. Okay, now if these two expressions are the same, then we can conclude here that your differential equation is an exact, or let's say your first order differential equation is an exact differential equation. So there's a particular examples here, or there are examples that will help you fully understand this particular partial differentiation. And actually, this was already covered in your EMA 101, in your differential calculus. Okay, so the differential equation of the form m of x and y dx plus n of x and y dy equal to 0 is an exact equation if there is this function f of x and y such that the differential of f is equal to the sum of the m of x and y dx plus n of x and y dy, which is also equal to 0. Then we can say that the function of x and y is a solution of that particular differential equation. So you have this particular relationship that you need to recall, because we will remember them again later when we perform already the process of determining the solution of your exact differential equation. That is after you have already tested for exactness. Okay, so the partial of f with respect to x is actually this m, and the partial derivative of f with respect to y is actually this n. These two, you need to determine, that way you'll find the solution of your exact differential equation. Now, this one, this is part already of the solution of your exact differential equation, whereas, let me clear this one so that you will not be confused, whereas this one here, this one is the test. It's not part of the solution of determining the solution of an exact DE, but rather this is the test that you will perform. The one that you see in the other side, on the other slide, is already part of the procedure. Okay, so you only have to remember three things. The partial derivative of m with respect to y should be equal to the partial derivative of n with respect to x. That way your DE is said to be exact. When it is exact already, you need to know this relationship. That way you can partially integrate with respect to the variables that appear here in the partial differentials of f, which represents the solution of the exact DE. Now, I would like to clear things up by giving you now a specific example. Now, when we talk about determining the solution of an exact DE, there are actually three different methods that you can use. You can only use one if you can use method 1, method 2, or method 3. Whereas method 2 and 3 is actually just, shall I say, comparable to each other. It's just the opposite. One is the opposite of another. But in these three methods class, let me emphasize that I always find it easy for the student to understand this method 1. Although still, I'd like to discuss the other two methods, because later on you may be handling different reference textbooks that discusses the solution of an exact DE using those two methods. So I'd like to first discuss method 1. So method 1 requires you to integrate. Take note, integrate what? The partial derivative of f with respect to x, which is actually your m. It is your m. Now, you are to integrate it with respect to x, considering the other variable y if it appears on it as a constant. So just like when you do partial differentiation, there is also what we call partial integration. If you integrate with respect to x, the variable y is considered a constant. If you integrate with respect to y, just like in this case, which is your n, the other variable, which is x, is considered a constant. So then what you do after integrating the two, term by term, should be compared with each other. So the terms present in this f and the terms present in this f, you will compare, and you will singly pick out the terms that appear, whether common or uncommon, between these two. And those terms now, the sum of those terms will constitute the solution of your exact first order differential equation. So this one is more straightforward than the other two methods that I'm going to discuss. Now, this is the example for that. So, solve the differential equation dxy, or rather 2xy dx plus the quantity x squared plus 3y squared dy equal to 0. Let me annotate first. So, this one, the m is your 2xy and your n is x squared plus 3y squared. Now, to test the homogeneity, if you recall in the first slide, you will partially differentiate m with respect to y. Why is that? Because the variable here in the differential of the m is x. So you will differentiate m with respect to the other variable. Then that would be y. So if we do that, class, if you differentiate this with respect to y, x is a constant. That was already learned in your calculus. So if you partially differentiate with respect to y, variable x is considered a constant. So you could see here that the answer is 2x. Now, if we go here on the other side, if you partially differentiate this with respect to x, because the variable that appears in the differential is y, this one, the second term, will be 0 because your y is considered a constant. And the derivative of a constant is 0. So that leaves you x squared to differentiate with respect to x. And the answer for that is 2x. Now, since these two partial derivatives of m with respect to y and n with respect to x are equal, we say that your differential equation is exact. Now, when it is exact, this is the time for us to use method 1, the one that I just mentioned a while ago. So what is that particular method? It will require you to integrate m with respect to x. But the process of integration is partial integration. So meaning if your m contains a y is considered a constant. So what we did here is copy the m, this is your m, equate it to the partial derivative of f with respect to x because of what was discussed to you in the second page. That partial derivative of f with respect to x is equal to m for method 1. And you will partially integrate it with respect to x. So take note, you partially differentiated with respect to y for testing, but in finding the solution, you partially integrated with respect to x. So when you integrate this with respect to x, x is the only thing that you will integrate using power rule because 2 and y are considered constants. So your answer is x squared actually over 2, which cancels these 2 in here, giving you an answer which is x squared y. You do the same for the n, which is equated to the partial derivative of f with respect to y. So now you will integrate this expression of n with respect to y. So x is considered a constant. So meaning this x squared is in the entire thing is a constant. So x squared partial differential of y will be x squared y. And integrating 3y squared using power rule will yield y cubed because this would be 3y cubed over 3. So that would be y cubed. Now look very closely. Okay, look very closely that the f here in your first partial integration has x squared y. Your f in the second partial integration has also x squared y, but has another term which is y cubed. So what we do, class, in this particular method is we pick out the terms that are common, and that would be x squared plus y, and also the terms that are not common. So the y cube is also appearing here, so you copy it. And then just simply affix on the right side of your solution C, which is your arbitrary constant. So the solution of this differential equation originally given to you is this one already. What if, you may ask, what if, miss, for example, you have here another term, let's say y over 2. Y over 2, just like y cube here, is not common between these two f's. You still need to add it here. So you have to add here plus y over 2. So what you do in method 1 is compare the two f's, pick out the common. You don't add them. You just simply pick it out and even pick out the uncommons and reflect all such terms in your solution. So if this is the case, just for as an example, if this f contains y over 2 as the second term, your y over 2 here should be also appearing in the solution of your exact differential equation. Do you get it, class? So I hope you can follow through. Before I clear the drawings, do you have any question? Okay, so I will clear the drawings now. Okay, I will go to the next page. So this is how you use method 1. It's actually the most direct and the easiest method to use in determining solution of exact differential equations. Okay, what about method 2? So it has also 2 steps, but a little bit you will use both uh, integration integration and partial differentiation at the same time. In method 1, you only use partial differentiation. Take note, in testing only. Partial differentiation does not anymore appear as a procedure in determining the solution. In method 2 here, both partial integration and partial differentiation still are being used in the solution itself of your exact DE. So what is the first step here? You integrate your partial derivative of f with respect to x, which is actually your m, in your original DE with respect to x, holding y constant. So that's the first term. And since you're integrating f with respect to x, then there is this arbitrary constant in this particular method, which is labeled to be a function of g of y. So the question is, what is this g of y? So to answer that question is, you need to perform the second procedure. You differentiate f with respect to y and equate it to n. What do you mean? Your answer here, you will have an answer here. You differentiate it with respect to y, and the corresponding expression you equate to n, the n in your original DE. Then you'll be able to find the g of y there. When you're able to find the g of y there, you go back here in your answer, in your solution, and add it to the integral of the first term. That will now constitute the solution of your exact differential equation. So integrate and then find the g of y by differentiating. And go back to the original integral that you have and substitute the g of y. Okay, now I think it would be clearer if there's a specific example for this one. Let me proceed with the next slide. Okay, example. So this is your 3x times the quantity xy minus 2 dx plus x cubed plus 2y dy equal to 0. Of course, before you even attempt to do the procedure of exact DE, first test. So ano ang test? Differentiate this one with respect to y. So before you differentiate, since you have a product of two expressions here, expand first. So distributing, you will have 3x squared y for the first term, and your second term will be negative 6x. Then you are ready to partially differentiate your m with respect to y. Since this contains all an x, this will be a 0 because x here is considered a constant. If you differentiate here with respect to y, that would be 3x squared. What about this one? You also partially differentiate with respect to x this time because the differential that appears here is y. So you see here partial derivative of n with respect to x. So with respect to x, this is being considered a constant. So your partial derivative would be 3x squared. So now we have established that your original differential equation or the DE that was given to you is exact. So now we use the two-step procedure in method 2. First procedure is integrate the partial derivative of f with respect to x, which is your m, meaning you copy the entire m here, with respect to x. With respect to x, then y is considered a constant. So if you do that, class, you just transfer, let me annotate. You just transfer this partial differential here. This goes here. I'll get it here. So it will now appear here, partial differential with respect to x. And you do partial integration, both sides. The answer would be this. So you will drop the differential symbol, the curly D symbol. So this would be an F. And you use power rule. But this time you consider y a constant. So if you integrate this one, this would be x cubed because the 3 will cancel out if this is done using power rule. So x cubed y, if this is integrated with respect to x, this would be 6x squared over 2, or that would be 3x squared. And you have this, the g of y, which will require you to perform procedure number 2. What will you do? This answer of yours in the first procedure, you will differentiate with respect to y. So differentiating it with respect to y, x cubed plus g of y prime is equal to this one. So if you're going to differentiate it with respect to y, you will have this one. If you differentiate it with respect to y, you have x cubed, and this one is all in x, so that would be equal to 0. So you have x cubed plus g prime of y is equal to x cubed plus 2y. Now, you may ask, Miss, di niya siya naghalin. Ang differentiate mo halin sa f with respect to y. Naghalin na siya diri sa imo original na di. This is your n, which you will equate to the partial derivative of f with respect to y. So, amo ni siyang iyang partial derivative. If you notice, class, if you equate, this cancels this one, and that leaves you with g prime of y, which is actually the derivative of your g of y when represented in a general expression. This one is a function of y, but you don't know specifically what function of y is it. So you will just simply represent it as g prime of y, meaning it's the derivative of g of y. Okay, so this letter B that you have is actually the partial derivative of this f of yours with respect to y, so that it will not be as direct as this one. So it will yield this particular answer here, x cubed, because your y here is differentiated. So you have x cubed, this one will be 0, and this one will be g prime of y. You equate with n, that one, so this is your n, and you have g prime of y. We don't need g prime of y, we need g of y that you will place in here. So there's a need for you to integrate so that you get rid of the prime. So g of y is 2y squared over 2, or that would be y squared. So meaning this g of y that you see in the first procedure now is y squared. This is your y squared. And this is your y squared here. And you copy. So x cubed minus 3x squared. And what is this g of y? This is your g of y now, which is y squared. And just affix the c. Now, when you are asked what's the solution of your DOE, don't include this one. You just simply write x cubed y minus 3x squared plus y squared equal to c. Question, will I always write the c on the right side? The answer is yes. The c is always written on the right side. Now, before I mention the next method and before I erase everything here, I'm now ready for your questions. If there are questions or clarifications that you'd like to raise. Have any questions? Okay, so there's one here in the chat box. This question, but where did G prime came from? Okay, sige. The G prime came from, remember that you want to find the G of Y here in the first procedure in which you partially integrated your M with respect to X. So you have this constant. Your constant is represented by G of Y. Now, the second procedure requires you to differentiate this answer of yours with respect to Y. So when you differentiate with respect to Y, this one will be considered this one, the 3x squared, will be considered as a constant. Constant siya kay y ang imo nga gina-differentiate. So what will happen is the second term will be 0. And if you differentiate the first term with respect to y, your answer will be x cubed. So you see this? This is x cubed plus this one is 0, ang partial derivative with y. What is the derivative of just g of y, which is general expression for a function of y? That's your g prime of y. you do not know what is that. So you just also represent it in a more general form. And what you do with this partial derivative of f with respect to y, you equate it with n. This n here in your original DE. And you do partial integration again. Actually, you just integrated with respect to y because there's no other variable here. You need to integrate because what is left here is g prime of y, and what you need is g of y. So this is your g of y. The g of y, which is y squared, is now substituted to the original f expression that you got using the first step in the procedure. Did I answer that? Okay. Okay. What about the rest? Is it clear? Okay, so let me just clear my markings here. And we go to the last method. By the way, class, you just choose the method that you're comfortable with in using. But there are instances, but it's not always, class. It's just, shall I say, probability of it occurring will be 5%. Okay, so 95% method 1 will be able to determine the solution of the exact DE. But there are DEs that requires also that you will really need either method 2 or method 3. That is why this one is being discussed. Okay. Now, I will proceed to the next page. Okay. Your method 3 class is just the, shall I say, related in a form to method 2, only this time you did not integrated f with respect to x, but integrated f with respect to y. So this time, the one that you integrated is actually n. It's n. So n of dy, and you will again have an arbitrary constant, which is f of x. So the second procedure will tell you that how to find the f of x. So how do you find f of x? Your answer here in the first procedure, you partially differentiate with respect to x and you equate it with m. And method 2 is you equate with respect to n, then solve for f of x. Okay, now I think it will be clearer if I will go to the specific example. Okay, so this one will illustrate method 3. Okay, this is the same. This is the original DE I gave in method 2. So we tested with exactness. This is exact. But this time we will use n, which is the partial derivative of f with respect to y. So this is it. Now you will integrate this expression with respect to y. Okay, you will integrate it with respect to y. So this one, when integrated with respect to y, class will be x cubed y. So I wrote it here. When you integrate this with respect to y, this would be 2y squared over 2, and that would be y squared. Notice this time that your function is not g of y, but rather, let me use the annotation, but rather it's now f of x, because in the first place you did not partially integrated with respect to x, but rather you partially integrated with respect to y. So the constant that you will have here is a function of x. How do you find this? So if in the other method you use partial differentiation with respect to y, this one will require you to perform partial differentiation with respect to x. Okay, so if you will do that, this one is 0 because it's a y, it's a constant. This one is 3x squared y plus, what's the partial derivative of this with respect to x? That would be f prime of x. In the method 2, we have g prime of y. So that's what you're seeing here. Okay? What you do, you don't equate this with respect to n, but rather you equate it with respect to m. This is actually your m. It's now covered there, okay, by my annotation. So let me close first. So this is your m. 3x squared y minus 6x. Okay, we equated it to your answer here. What do you notice? What do you notice? You can cancel this, leaving you with f prime of x minus 6x, which requires you to integrate. So if you integrate, you will have f of x equal to, if you integrate this would be negative 6x squared over 2. So that would be negative 3x squared. Telling you class, that this f of x of yours is now negative 3x squared. So your solution is this. The solution of your DE using method 3 is exactly the same as the one we got in method 2. You copy x cubed y plus y squared here plus the f of x, which is negative 3x squared, and equated it to c. Okay? Now, before I erase everything, do you have any questions? So this is method 3 applied to this same DE that was given to you in method 2, just to illustrate that the two methods actually is just in terms of pattern similar with each other. So it will yield the same answer. Any question here?
Miss, excuse miss. Ang sa
Okay,
negative x, sa B miss, ang negative x, ano na miss, 2x ang next ya?
negative
Ang
x. Letter B, this one.
negative 6x miss. Miss.
Ano, this is curly D. This is partial. This is partial derivative, partial differential of x. That's not a 2. You're
Okay, miss.
partially
Thank you.
integrating with respect to x. So it is a curly D. That's not a 2. Just like this one. Question? No more question? So what will happen if this particular DE that we have is solved using method 1? You may ask it, Miss Abby, method 1. Okay, since we have the time, we will solve this using method 1. So let me share to you the Jamboard. Okay, wait, guys. We'll have a different path. Okay, so our M there is, okay, let me just check the PowerPoint class. So our M is 3x squared y minus 6x. 3x squared y. Wait, class, ha? It's 3x squared y minus 6x. 3x squared y minus 6x. Okay, later, Juliana, ha? Mama's doing something. So 3x squared minus 3x squared y minus 6x. Let me check, class. Okay, your n is x cubed plus 2y. X cubed plus 2y. Where's the jumbo? X cubed plus 2. Oh, are you seeing the Jamboard?
Yes, miss.
I can't see it from my end. Wait, class, ha? I need to stop share. Problem with Miss Ali, I'm very forgetful. Wait lang. I'll first write it, then we can go to the procedure because I keep on changing x cubed plus 2y. Okay, now I will write again. So this is your 3x squared y minus 6x dx plus x cubed plus 2y dy equal to 0. I just wrote it first so I can share it to you, class, without having to change slides. Share screen. Okay. Okay. Can you see my Jamboard? Just a thumbs up sign would do. Can you see the Jamboard? Okay, thank you for that. Okay, we will solve this original, this DE, which we solve using method 2 and 3 using method 1. So what did method 1 ask you, if you can recall? What was done in method 1? It's the simplest of the three methods. Anyone who can recall what is method 1? Hmm? We have 15 minutes, so I will waste my 15 minutes. Anybody who recall what is method 1? It's more straightforward.
You integrate f with respect to x, miss. Tapos,
And
integrate f with respect to y.
and what? Christian, Alexis. You will compare. You will compare. That's how easy it is. So we will do that. Very good, Christian. Okay. So I will minimize this one. So I will integrate f with respect to x. Now, of course, I need to copy my m. Okay. After this, I will have partial derivative of f equated to 3x squared y minus 6x. And we will have the partial differential of x. Then we will integrate. Then you will have f. I'd like to have here a subscript 1. F1 is equal to, since you are integrating with respect to x, that would be x cubed y minus, so this one is 3x squared. That's F1. What will happen now? Go to page 2 if n will be partially integrated with respect to y. So partial derivative of n with respect to y is equal to x cubed plus 2y. Let me go back, class, to check. Okay. And then transfer partial differential of n is x cubed plus 2y. Okay, we multiply it with the partial differential of y. Then integrate. What we do, n is equal to x cubed y plus y squared. Now, let me compare the two. So you have this x cubed y minus 3x squared. By the way, this one is not f. What did I place here? This is, by the way, f. You may get confused. This is f, not n. So this is f. This is f. And let's say this is f2. So your f1, I'll place here, is x cubed y minus, I forgot again, so we go back here, 3x squared. 3x squared. So if you recall the procedure under method 1, check for what is common. So what is common would be this term, this whole term, and these are uncommon. So therefore, I place here, the solution of your exact DE will constitute these terms. The sum of these terms, minus 3x squared plus y squared equal to c. See? So now you can compare which of the three methods discussed you like better. So this one, this two-page solution in here, only constitute partially integrating m and n. This is partial integration with respect to x for your m and partial integration with respect to y for your n. And then compare the common and the uncommon terms and copy. And that's it. Do you have any questions? It's up to you which of the three methods really you're going to use. Any clarification, any questions? you will have an early dismissal today if you don't have any questions. So after this, I will post the recording and then I will give you sample problems for the 3 topics discussed already: separable, homogeneous, and exact. And you can study this for your next week's quiz. So for Wednesday, I give that to you for your asynchronous task. You look for the problem in the problem set, which is exact, and solve it using the technique that we just discussed today. Okay, and then prepare for your other hour, which is also asynchronous. Prepare for your quiz on Monday. Okay, I will stop sharing now. Okay, I will stop recording. And by the way, class, before I stop recording, can you place on the chat box your name and present beside it? That way it will be included in the recording. So I can check the attendance because we check only attendance in the synchronous meetings. Okay, name, family name, and then write present beside your name. Thank you. Castillo Aquino, Santua, Dalisa, Espinosa, Manangkil, Alicen, Dompor, Dizon, Ramos, Gonzaga, Umas, Mayote, Javier Lachica, Inventor, Malapitan, Pila, Quaicong, Casiano, Delgado, De Velos. Okay. Laho. Tupas. There's 38, 37. Sombero. Thank you, my dear ECE students. Do you still have questions? Gonzaga. Thank you. So I'll scroll up again so I can record attendance. Any question? So everybody has their group mates already. The Lumen, Leonato Villarosa, Gonzaga. Okay, if there are no more questions, class, just message me should you encounter a problem later on that you might need my assistance. Okay? Okay, bye for now. I'll see you next week. Thank you, everybody. Have a nice weekend and have a nice week ahead.
Bye, miss.
Goodbye.
Thank you, miss.
Thank
Bye-bye.
you, miss.
Thank
Thank
you
you,
also.
Miss.
Thank you.
Thank you, miss.
Take care.
Thank you.